Let's talk some renewable energy. I'll be honest with you, the people that sit on the advisory board for the Dillard Energy Center don't know why I talk about renewables in this course at all. And I tell them two reasons. First is you, the student body, are interested. You're very informed on these issues, and you want to hear the story of how all this fits in. And the second thing is, if we're talking about educating students for a career in the energy industry, then you need to have the facts about where the energy industry is so that you can form your own opinions about where the energy industry is going. So today, well, I shouldn't say just today, but through the series of videos and through the class discussion, we're going to try to give you a grounding in some of the very basic physical principles, some of the trade-offs that are involved as how these goods fit into the electricity grid. And then we're going to look at the business cases that affect the future of the renewable industry, and for that matter, the fossil fuel industry. But I want to be real from the very beginning in this discussion. I'm going to tell you personally where I come down. Do I think that the amount of carbon dioxide in the atmosphere is higher than it ever has, or than it has been since it's been tracked, which has been about 150 years, due to man-made activities? Sure, of course. I mean, that's, to me, a demonstrable scientific fact. Do I think it's having an impact on the U.S. climate? Probably, but to what degree, I'm not sure. And my frustration is, as someone that I consider to be very fact-based and very open-minded about let's let the facts see where they lead, it's very dismaying to me that any science-based discussion about these issues quickly become highly politicized by both poles and people making fairly easily refuted outrageous claims on both sides, and so you're not really sure what you can strip away as myth and what you need to adopt as fact. So I'm frustrated by that personally, and perhaps you are too. But I want to offer a little bit of historical perspective. This idea of man makes progress, it creates a lot of environmental impact that needs to be addressed, and there's always a battle around that rebalancing. That's not new. When in England, when they industrialized with the coal as the source of fuel, the smog and the pollution from the coal burning was awful. Well, that got addressed. If you think earlier in the class, we talked about the Clean Water Act and the Clean Air Act that were passed in around 1970 or in the early 1970s. Those were all responses to pollution growth that we saw in the United States. And frankly, the smog, the dirty water, that stuff has been largely eradicated, and it's been eradicated without destroying the industry that was creating them. So there's a lot of balance historically that's happened, and now we're in yet another issue of that balance with the greenhouse gases. How it's going to come out, I don't know, but we've managed to come out of these debates in the past. You're going to see we're going to talk a lot about electricity in this session, and that's because renewables at this point all generate electricity. Therefore, you have to look at electricity usage and possible additional usages for electricity as you go along. And so I want to tell you there are two important questions that tie back to economics, because this is a business class, that you want to be considering. And the first is, how do you properly charge for pollution? So an argument against the fossil fuel industry would be, you've been allowed to pollute by these CO2 emissions for all of these years, but you haven't had to pay for it. That's a very, when I say it's a valid question, that's what I mean. I'm not supposing the answer, but it's a fair issue. And that's why you see companies like ExxonMobil, believe it or not, that have come out in favor of a carbon tax. We're hopefully going to see some papers presented on that issue towards the end of the semester, so I don't want to get too much into that discussion. But think about that. Why would ExxonMobil support a carbon tax? And it does, and they're not the only ones who do. The flip side, though, is the question that you probably haven't heard ever, and that is, what should be the charge for a lack of reliability of a power source? In the electrical industry, it's called dispatchability. Can we turn it on? Can we turn it off? And let me illustrate to you in a very silly question just how important this is. If I say to you, what's your minimum acceptable standard of performance for when you flip a light switch on, you expect the light switch to come on, or when you turn the air conditioner on, you expect the air conditioner to come on. Well, I often will ask this to undergraduate audiences when I'm doing very speaking engagements, and of course I get this stupid look like, well, duh, 100%. I always expect it to work. Yes, in the first world, we always expect the electricity to be there, the natural gas to be there, the gasoline to be there when we want it. But the reality is, currently, renewables are not that way. They suffer from the problem of intermittency that we're going to talk about. And until you deal with that, how should they be charged, if you will, for the fact that they're not always available? We're seeing this currently. As I make this video in 2017, there's a lot of blowback on a Department of Energy proposal to give a credit, if you will, to coal plants and nuclear power electrical generation plants. And there's a lot of politics involved in that. I'm not supporting that. But at its core, it has a valid issue, which is those are some of the most reliable power plants in America. Should they be given economic credit for always being there? And it's a fair question. Now, every one of us comes to this topic with their biases. I've already told you my bias. I think that probably there's going to be some balancing in the future about greenhouse gas emissions. Frankly, I'm from Kentucky, which is a huge coal state. I don't think the coal industry is ever coming back, and I don't think it should necessarily, because we figured out lower pollution ways to change things. Now, if they get better with carbon capture technology, so that we can burn coal without the negative environmental impacts, then coal will have and should have a resurgence, perhaps. But I have my biases. I believe that the renewables are a little bit overhyped. I believe I'm going to present some facts to you that are just that. They're facts that are going to give you a little bit more balanced view of them. So I have my biases. You do too. I'm going to do my very best to present unbiased information to you in this presentation. Obviously, when you hear something about the environmental impact of renewables from the American Petroleum Institute, you know that's a biased source. Likewise, when you hear about all the accomplishments of green energy from the American Wind Industry Association, you know that that's a biased source. That's not to say you can't use those sources, it just means it says you have to separate the fact from the spin or from the interpretation. So as I go through the presentation, I'm going to try to tell you what the sources of the information are so that you can assess the level of bias that's likely to be in any of this information. So why are renewables so popular? Well, the sentiment is that the fuel source is perpetual, that obviously there are much lower greenhouse gas emissions, and they even have environmental impact beyond the lower greenhouse gas emissions, specifically, for example, fracking and perceived threat to the water tables. Well, now let's push back on some of those claims. And I'm going to tell you right up front, some of the issues on this slide are very small, and some of them are, I think, much more significant. So the reality is renewables are not free. They're very expensive systems to develop, and they're expensive systems to maintain. Furthermore, they are not greenhouse gas emission free. There are a lot of greenhouse gas emitted in the construction, and in some cases, even with the continuing operations. They are also not, quote unquote, perfectly environmental friendly. The idea of damage to birds, really hard to get numbers on that, and impact on livestock and the like. Probably all those things are probably doable, but there are two things I think that are very real that are going to get more attention. The first is a lot of electrical components that run electric motors and generators and the like are composed of things called rare earth minerals. They're not called rare earth because there's not much of them on the earth. They're called rare earth because they're widely dispersed. So you have to do a lot of mining of soil in many cases to be able to create the rare earth minerals that are used in a lot of these generators and those sorts of things. Well, that's actually a very polluting thing. The majority of rare earth minerals currently come out of China, and the reason for that is they have very weak environmental regulations. And so what is a fairly ugly environmental process is done in a place where that's permitted. As China ratchets down on that, and they are, you're going to see the cost go up of the rare earth minerals, and that's going to affect the economic calculation because they've been doing some pretty ugly things to the environment in the process of mining those rare earth minerals. But I'm sure that it can get better through technology, improved practices. There will be a cost impact, but that cost impact will probably be successfully managed, just like many cost impacts are. The other issue that I think is real is the visual pollution. I personally think the wind turbines are pretty ugly. And if you were to build one near my property, I would feel like that you diminish the value of my property. You're going to see that's an issue. I'm not alone. There are plenty of states and towns that are in this battle right now because they want wind turbines, but they don't want to be able to see them, to include some pretty green states. Also, currently, to move electricity around the country is done on the electrical wires, which are above the surface. And so unlike a pipeline where you tear up the ground, you bury the pipeline, you cover it over, and frankly, most people don't know that the pipelines are even there. You always see the electrical lines, and that's an issue. It's an issue to me, and I know it's an issue to other people as well. Finally, there are some very real operational issues. I've already hinted on this idea of intermittency. If you are a wind advocate, then you have to be aware that when does the wind tend to blow the most? In the spring, in the fall, during the nighttime hours, when electrical demand is at its lowest. And so many of the times when electrical demand is at its highest is not when wind turbines tend to operate very well. And so you get that bit of intermittency. One strength of solar panels is if you're in a hot climate, they do tend to produce the most power when it's needed, because when the sun's out and the temperatures are rising, that's when the solar panels are producing. Then you have the other issue of location. In a lot of cases, where it's possible to generate that power is not where it's needed. And so now we have to transmit it or convey it to where it's needed. Again, the pipeline technology is relatively inexpensive and fairly well developed, not nearly the case for the electrical grid capacity in terms of moving electricity long distances. Now, I'll step out here. One thing we're not going to talk about at all in this presentation is offshore wind. That's just now beginning to make some progress on the east coast of the United States, although offshore wind currently is much more expensive than onshore wind. Although costs, the more proficiency you get, the costs are coming down, and we're going to be talking about costs. The costs are coming down, but that would be a game changer a little bit in the wind industry. If they're able to put a bunch of wind turbines off the east coast of the United States where there's a high demand for electricity, that really would be pretty remarkable because the transmission would not be an issue. So I'm going to stop this video, and in the next video we're going to get into the idea of electricity.